In this video lecture series, we're going to be talking about biofuel, and you're probably wondering, why? Biofuel? Isn't that an energy source? What does that have anything to do with food chemistry? Well, the answer is everything. If it wasn't really for food product, we wouldn't have biofuel and many other resources that we take for granted and use every day. So in this lecture, we're going to take a closer look at this definition of biofuel. We're going to take a look at the history of fuel altogether, way back before the 1900s, and we're going to track it up until today. And then we are also going to discuss the role that our food industry has played in this whole field. Now, one of the first things that I want to talk about is this picture. Yeah, more protesters. I mean, if you've taken a look at the genetically modified lecture folder and those videos, we saw protesters that were protesting genetically modified food. Well, it shouldn't come to a surprise that we also have protesters that protest the oil industry. As you can see here, the face of this protest is a woman in the dead center of the picture who is dressed in kind of robe gowns and crowns. Those crowns are probably made of leaves, and the jewelry that she has on her dress are probably some kind of symbol to the earth. And she's holding up a sign with the BP logo, and she's ripping it in half. Well, what's funny about this is that her and all of the other people that you see in that picture are basically telling you that oil is bad. But what they probably don't tell you is that all of those protesters in that picture probably used oil to get to the protest that they are now at. They probably did not think anything about getting into their cars and putting oil, aka gasoline, in their vehicles to come to this protest. They probably didn't think about the oil and gas industry helping make the rubber that they put onto the tires that get them to that protest that they are now protesting. A lot of the fake jewelry, like the crown that's on her head, is probably made up of some type of rubber or plasticizer, and all of that is also really given credit to the oil industry. If it wasn't for what they do, we would not have those resources. So the issue here is really, what exactly are they protesting? They're ripping up the BP sign, but yet they utilize the services every day and they don't think anything of it. Here's another picture. Billionaire polluters. Stop wrecking our climate. No BP. And again, if you probably had a guess, I would say that these people utilized gasoline in a vehicle at some point in their life. But yet they probably weren't protesting it during that time, were they? Here's another picture of more protesters. Clean energy now. More wind spills. Planet and people, not oil money. Sun, wind, and water's good. Oil's bad. No more oil crimes. But once again, how did these protesters get to the protest? I guarantee you that many of them got into their car, used the oil to get to that protest so they could hold up these signs. So what exactly are they protesting? Well, maybe they're protesting the idea that oil is not the only option for our fuel. It seems like we give a lot of credit to the oil industry. We rely on the oil industry quite a bit, and that's happened for a number of years now. So maybe these people are really protesting the idea that oil is not the only energy resource, that maybe things like water energy, solar energy, wind energy, maybe those should be an alternative. But that's not what these signs actually say, now is it? It's actually saying do away with oil completely. We don't want anything to do with it. Here's another sign. Boycott. Boycott BP. Don't go to the gasoline pumps. Don't get into your car. Don't get into anything motorized because we are protesting that. Well, if these people didn't get into their vehicle to get to the protest, these people could have used public transportation to get to the protest. And that public transportation, guess what? That runs off of gas. Well, maybe these people don't have a traditional gasoline vehicle. Maybe they are, more environmental friendly. Maybe they've sunk in a little bit of extra money to buy a fully electric vehicle. They don't need gas. Well, that electric vehicle has to be plugged up. Where do you think that energy comes from? That electric car has to be powered by electric, and that electric, in an indirect way, is getting their energy from the gasoline companies. The oil industry, that is where it originates from. I mean, where else do you think your electric comes from in your house, right? So this concept that we should become oil independent is actually an idea that probably never will happen. We rely on oil for too many things, not just for gasoline tanks, but many other products that we use on a daily basis. Just simply think of plastic. In an indirect way, plastic production is related to the oil industry. Every time you go out, every time that you purchase something, if it comes into a container in a store, and that is a plastic container, that is indirectly related to the oil industry in some form or in some fashion. What you're seeing on the graph right now is basically a breakdown from the year of 1800 all the way up until 2016 when this graph was generated. This is telling you the global fossil fuel consumption. And it's giving you a breakdown of the 3 different categories that are very common. These categories are, number 1 is coal over here to the right-hand side. And then we have something called crude oil. And then we have something, of course, that's called natural gas. Well, as you can take a look, 1800, we have very little of anything, really. And 1850s is kind of the moment that this begins to grow a little bit. After 1850, we actually see kind of a target on the graph. We can see some area under that curve. But it looks like it was mainly coal up to this point, or coal-related. And again, this is just fossil fuel. So after 1850, we start to see an uptick in that energy consumption. And that energy consumption mainly was due to coal for the most part. 1900s, we start to see a verge here. And that verge is going from coal into something that we call crude oil. And then after the 1900s, a little bit after, not much, but we start to see a green line, right? So down here, 1930s, somewhere in there, we start to see the vergence or emergence of natural gas. Those are really the 3 major categories for our energy consumption even today. That's it, folks. That's what you get. It's either going to come from coal, it's going to come from crude oil, or it's going to come from natural gas. It's going to be one or the other. Now, depending on what you're doing, depending on what you're driving, depending on what you're using, it's going to come from one of these resources. I hate to break it to you, but that's the way the world works. Well, if we start tracking the colors here, and we start looking at 2016 era, it looks like coal has taken a dip. Right? We see that little hump right there. It's beginning to go down a little bit. Crude oil looks like it's kind of flattened. It's not went down. Natural gas looks like it's starting to creep up maybe a little bit more. And this gives us an idea of the projection. Where is this going to go? Crude oil, it's probably going to continue to increase. To be honest with you, it's going to increase over a number of years. Natural gas, more and more people have access to it. Because of that, over a course of years, it's getting used more and more. And then finally, coal. Coal has taken its own time. Coal has had its own history. But coal is going to be around For the most part, it is an energy resource that we still rely on. Now, this thing can tick down a little bit, but those are due to some other reasons. Not because we don't want to use it, but it's due to some other reasons that we'll talk about here in the next few slides or the next video too. Here's another graph. Energy consumption in the United States. Again, this goes all the way back prior to 1800 up into 2018. The black line that you see on the graph is related to coal. And we see that coal takes a big merge or surgence here. Up it goes. And then it begins to kind of falter a little bit. And then after the 1950s, it goes up, 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 up. And then about 2016, 2015, we start to see a change in the direction of coal, and it begins to plummet. And again, this stops at 2018. So something's happening here with coal. Something's happening with the coal industry. We need to figure out what that is because that is an energy resource that we have. All right, if we take a look at the brown line is petroleum or crude oil. Well, if we take a look at the 1900s, this begins to skyrocket and it really takes off and it beats out all of the other competitors. Even today in 2018, it is one of the highest energy reserves that we have. This is where we get a lot of our energy from petroleum. So this is an area that's going to be around for quite some time. Natural gas. Again, as more people get access to natural gas, as more natural gas lines are getting laid when new houses are built and so forth, more people are beginning to use it. So over time, of course, the usage of natural gas has increased and it's on the rise. Again, probably an area that's never going to go away. But we want to focus on the bottom part of this graph. Very little amount of energy consumption is coming from those categories. Hydroelectric. Well, you probably know what this means. Hydro means water, right? And this is basically electric power that's generated through water, aka think of a dam. Biomass. This is probably one of the ones that we're going to be talking about for the most part in this lecture series. What is biomass? How can that give me an energy resource? What are the steps that are involved in it? Nuclear. Nuclear is a powerhouse when it comes to energy consumption and energy supplier. It's all over the place. So why aren't we doing more with nuclear energy? Well, as you can imagine, some people believe that if we open up this box of worms and we make it more common, then these nuclear disasters could maybe occur more often. And we do not want that, right? So nuclear has increased over time, but it has stayed very low compared to coal, natural gas, and petroleum. And then finally, the other renewables. This would be things like solar and wind. Those are renewable sources. And as we can see, really for the most part, all the way up into the 2000s, we just don't really care about renewables. And then in about 2016, we start to see an uptick that begins to happen with these renewable sources. We're using a little bit more wind, not much, but a little bit more. We're using a little bit more solar, not much again, but a little bit more. So based on the graphs, all of the ones down at the bottom, folks, they need a lot of work. They need a lot of work to become more mainstream. They need more work to become part of our daily life. Because ever since the 1800s, we really relied on three main categories, and those three main categories are still the categories that we look at today, and that's coal and natural gas and petroleum. But we're trying, okay? We're just going to have to get to a point where people become more acquainted with these alternative energy sources and more accepting of the alternative energy sources. But right now, the way that it is, it's coal, natural gas, and petroleum. Now, we need to talk about petroleum because this really is where our gasoline comes from. And this lecture is about biofuel, And in order to talk about biofuel, we're going to have to start with this idea of gasoline first, and then talk about the problems with it and how we try to fix it over the course of years, going back again before the 1800s. So what is really petroleum? Well, if you've ever watched the Beverly Hillbillies, you probably know what petroleum is. It's crude oil, or bubbling crude, which is how that show opens. It's basically what I would call raw oil. Comes straight up from the ground. All right, this is what we call petroleum. Petroleum is really a mixture of different hydrocarbons. And in the world of laboratory and in the world of chemistry, a hydrocarbon is basically a molecule that is made up of hydrogen and carbon, but I'm going to put here mainly, all right? It can still have some nitrogen, some oxygen, all of that is okay. Sulfur, phosphorus, all of those are perfectly fine, but hydrocarbon, the true definition of hydrocarbon, is just carbon and just hydrogen. So if we want to be true to the definition, then it is carbon and just hydrogen, and that's all. However, if we start throwing in nitrogens and oxygens and sulfurs and phosphoruses, it could still mainly be up of carbon and hydrogen. That's still okay. But this is really where the world of organic chemistry comes into play. So we redefine this and we say, well, it's an organic molecule. It might not be truly defined as a hydrocarbon, but it is an organic molecule, and we might be able to find these here and there sporadically in the mix, but petroleum is mainly hydrocarbon, which is molecules consisting of just carbon and just hydrogen. Now, in the petroleum category, this is a chemical soup of different hydrocarbons. And in this chemical soup, we are going to find things that we use for multiple purposes. One of those categories is gasoline, all right? So you can imagine this chemical soup of different organic compounds that are there, and a portion of that soup is going to be the noodle. That noodle could be gasoline, right? And then another portion of that soup could be the vegetable. And that vegetable, that could be a portion that we call kerosene. And we use that for a number of different reasons. And then another part of that soup, well, it might actually be the tomato broth that it's all kind of made in, right? Okay, well, that could be maybe diesel oil. That's category number 3, where there's tons of different categories in petroleum. These are just the 3 common ones because, again, we're talking about biofuels. But things like tar and asphalt also come from this petroleum, this crude oil that comes from the ground. Well, how do we separate all of these off? Well, this is the process of fractionation. And if you've taken our summer course, CTC 145, you have went through the process of fractionation. And if you've taken our maybe instrumentation course in the gas chromatography section, we do another fractionation. It's this whole concept that we can take a mixture and we can put a fractionation tube on it. And this fractionation tube, hold on, let me erase this because it's not really a condenser. And this fractionation tube will begin to separate all of the parts one from another. And then it gets sent through a condenser, and then over here it begins to drip into a receiving flask. So we've got this chemical soup, that's crude oil. We heat that up. Over time it gets hotter and hotter, but we heat it up slowly. And then those lower boiling point components begin to evaporate first, and then they will come over through the condensation tube and they will drip down into the receiving flask. And we continue to heat up that solution over a course of time. We continue to collect things in fractions, and all of a sudden I've got different compounds that are in front of me, different fractions. Well, the oil industry basically does the same thing. They take the crude oil and they heat this crude oil up in factories that look like this, what you're seeing here. And then over time, they are beginning to distill off different fractions of the crude oil. And they collect them. And when they collect them in different categories. And that really depends on their boiling points and their characteristics that come along with it. Here are some of the biggest oil companies that are in the United States at this point. We've got ExxonMobil, BP, Chevron, Shell, and ConocoPhillips. Well, you probably have heard of each one of these companies. They are major. They are powerhouses. Literally and figuratively speaking, they are powerhouses when it comes to the oil industry. So if you go out to your vehicle, and you probably have one, and if you pull up to a gas station and you put that gas into your vehicle, you have to thank one of these people for the most part, because if it wasn't for them, you would not have the transportation that you have, whether it's to leave your house to come to the college, to leave your house to go to a concert, to a party, to a friend's house, downtown to a bar. All of this is reliant on the oil companies that you see on the screen. So, are they necessarily bad? Well, these people are going to tell you that they are. You should not be purchasing gasoline for your car. Okay? These people are telling you that oil companies are billionaires. Well, they are. They are billionaires. And that's one of those reasons is because you have become reliant on the oil, because you require that oil to be there. Really, you do require it in order to have your daily life to function like normal. If it wasn't for these people, all of this would completely change. These people are telling you that you should get away from oil. You should really switch it up and go fully electric, even though electric also relies on oil in a roundabout way. So, are these oil companies bad? I'm going to let you make that decision. But they do play an integral and important role in everyone's daily life, including those protesters that do not want them to exist. Here's a job listing for a refinery lab technician. So, maybe this industry interests you. Maybe this oil, crude distillation kind of thing. Maybe you want to work for them. It is a very stable job. You're always going to have it. You're always going to have to put it into vehicles. It's always going to be required for transportations and asphalt and roads and everything. So this is a pretty stable industry. But if you look at the job description that you're seeing on your screen, this is coming from Shell. And down here, it says the accountabilities. What does it include? What would they like for you to know? Well, analytical instrumentation, Carl Fisher. Carl Fisher is just basically a water percentage. Okay, it is a titration, and it calculates the percent of water that is found. As you can imagine, we don't really want water in your gasoline, so that is a very important test that we have to do to make sure water is minimal. Density meters, we have one of those. You probably have used them. UV vis spectroscopy, well, check mark on that too. We've used that as well. X-ray fluorescence, combustion of sulfur nitrogen specific analyzers. Automatic distillation, you've done distillation. Flashpoint determination. Metrome titrators, look at there. We actually have that specific brand that they're asking in the job listing. GC chromatography, right? Gas chromatography. Applications with FID, flame ionization detectors. Check mark on that too. You'll use that somewhere along the way in our program. And mass spectrometer of both liquids and gases. We have mass spectroscopy, mainly in gases, not in liquid, but we have a GCMS system. They want you to be knowledgeable in high-pressure liquid chromatography and ion chromatography. Well, guess what, folks? Check and check. You've got those taken care of as well. The use of sample manager, Open Lab, LIM systems, basically software systems that operate this equipment, quality control, internal software. Can you use software? Can you use a computer? That basically is what that is. And perform preventative maintenance to analytical instrumentation. And if you've taken our instrumentation courses, you're going to see a big role is really devoted to this. So, you, as a chemical technology graduate, could easily go and work for companies like this if that is what interests you. In addition to that, these technician jobs, these entry-level chemist jobs for oil companies, they typically are a big money job. They make a lot of money, but at the same time, folks, they do pay their employees probably one of the best in our field. It's not the pharmaceutical company. Most people think, oh, pharmaceutical, I'm going to get paid a lot of money. No, it's the oil industry that is really one of the highest payers that are out there. Now, do we have oil companies like this in North Carolina? You're going to find most of these in states like Louisiana and Texas and so forth. So if this is the area that you want to dabble in, then that's probably the area that you're going to be moving to. Somewhere out Midwest, somewhere out in Texas and so forth. And we've had graduates in the past that have done it. And 2-year degree, they are making quite a bit of money, probably $20,000 to $30,000 more than what they would make in the state of North Carolina. Isn't that crazy? Here's another graph. And this graph is U.S. crude oil production. And this really goes from 1940 to a little bit past 2010. It goes to 2018. And if you look at the trend here, this is us producing oil. In the 1970s, we began producing quite a bit of oil. And the question is, well, why, right? Why did we cap out at this point? Something was going on. We'll talk about what that is. But during the 1970s, we began to see a peak in how much oil that we are producing as United States. After 1970s, then we start to see this trend go down, 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 down until we reach to about 2010. And then after 2010, we start to see a huge surge that happens with U.S. production, right? This is a concept that we started producing our own oil, and we were not reliant on foreign oil for our reserves or for our using. So we started producing more of our own. And if you take a look, 2018, we are now above what we were doing in 1970. So this gives you an idea, again, of the oil industry. Is it going anywhere? And the answer is, as of right now, no. As of right now, 2018, 2019, 2020, we are actually seeing probably one of the highest levels that we've ever seen as far as the United States producing their own oil that they want to use. Here's another graph, and it's what is this petroleum stuff really used for? Well, if you look at the graph, the largest part of the circle is road transportation. 48% is basically getting dedicated for this usage. But this petroleum is also used for many other things. If you take a look, aviation, so airplanes, shipping, domestic and international, residential, energy sector, industry, services, agriculture, almost every single facet of our life really is tied to the oil industry in some way, in some form, and in some fashion. So once again, where is it going to go? And the answer is probably nowhere. And that's because it is a very important resource that multiple people in industries require and use commonly. All right? The problem, though, is this can happen. Gas shortage. Limit 10 gallons of gas per customer. What do? This has happened a couple of times. This is a very important resource. We've already talked about the production. We've already talked about the usage, right? We've talked about the need that you need a gas to function every day. So what do we do as a country, and what do we do as around the globe, if the oil supply begins to plummet? What if there's no more enough to go around? What happens? How does our life change? We are that dependent on that particular resource. So in the next video, we'll pick up from here. How do we handle these types of problems? How do we rely on something so much that it really puts a standstill to everything that we do if you just completely take gasoline out of the picture? You are dependent on fuel. You always have been. We always will be. The answer and the solution to this problem is, where does that fuel come from?